In this video, we're going to be talking about some of the questions that are actually typically asked related to the quantum numbers. So let's start with this first question, which reads, which of the following subshells are valid? So a lot of time they give you multiple subshells and you have to figure out which one is a valid subshell and which one is not a valid subshell. And that strictly related to the value of n and the value of L. So if you recall, the value of n, which is a principal quantum number, could be anywhere from 1 all the way to the infinity. And the value of L, the requirement is it needs to be at least 1 less than the value of n. So as long as the value of L is less than the value of n, that's all really matters. Now let's look at this 4s first. So for 4s, the value of n is actually going to be equal to 4. And what's the value of L going to be? So remember, the value of L is actually dependent on the type of subshell you are in, which in this case is S subshell. It's going to be 0. So if you have a hard time figuring out what the value of L going to be, you need to watch the other tutorial where I have just talked about the quantum numbers. So now I have the value of n is actually less than the value of L, and that's all that really matters. So that means this quantum number is fine. Okay, let's look at the second one here. In 5p, the value of n is going to be 5, and what's the value of L going to be? Well, for p subshell, the value of L is actually going to be 1. So as long as the value of L is less than the value of n, then it's going to be a valid subshell. So that one is fine as well. Let's look at this 2D. The value of n, like it's coming from the number that's in front of the subshell, it's going to be 2. And the value of L is going to be, for D subshell, the value of L is actually 2 as well. So it's going to be 2 here. So that means it's going to be an invalid subshell. We cannot have the value of L to be the same as the value of n, and we cannot also have the value of L to be bigger than the value of n. So let's look at this 3f. In 3f, we have n is going to be equal to 3, and your L is, for f subshell, the value of L is going to be 3 as well. So that means this is going to be an invalid subshell as well. So that's one type of question they usually ask you to determine the validity of the subshells. Now let's look at the second question that they may ask you. They're asking you how many orbitals are there in the following subshells. Well, this should have been actually subshells, not the shells, so I'll just go and write that down here. Okay, so the first one is a 4p subshell. So when you are actually given the subshell, the number that's in front of it, it's invalid. Like it doesn't really matter. Like you can't really rely on the number of orbitals by looking at this number in front. It's mainly dependent on which particular subshell you are in. So since you are in P subshell, as long as it's valid subshell, your L value for the P subshell is going to be 1, so that means your M of L value is going to be -1, 0, and +1. So another way of saying, you're going to have 3 orbitals in there. All right, you don't necessarily have to do this all the time. Well, once you do it a few times, you will get a hang of it, and you will be able to get those quickly. Okay, so in any p subshell, a matter of fact, you're going to have 3 orbitals in there. Okay, whether it's in a 2p subshell or a 3p subshell, you will still have 3 orbitals total in there. Let's look at this 4d subshell. Now you are like this number in front of it doesn't really matter, so you're on the d subshell. And d subshell, the value of L is 2, so the value of M of L is going to be -2, -1, 0, +1, and +2. So there's actually 5 values in there, so that means there are going to be 5 orbitals in there. So in any given d subshell, whether it's in 3D, 4D, or 5D, you will have 5 orbitals in there. What about 6s subshell? So it's an s subshell, so value of L is going to be 0, so that means your M of L is also going to be 0. And since your M of L is 0, there's only one value for M of L, so that's going to be 1 orbital in there. So any given s subshell, whether it's 1s, 2s, 3s, it's going to have only one orbital in there. So it's very important to be able to figure out the number of orbitals in a given subshell before you can figure out how many maximum electrons you can place in a given subshell. Okay, what about this 1s subshell? Well, we just said that it doesn't matter which s subshell you are in, it's going to have the same number of orbitals because the L value is 0 and the M of L value is also 0, so that means you're going to have one orbital in there. Okay, so that's the other type of question you could be asked. Let's look at the third and probably the most common question is like figuring out how many maximum electrons are going to be in different categories. And this question could be asked different ways, so you got to be careful with how the wording is for that particular question. Let's look at this first one. It says 3s subshell. All right, so when they say subshell, then you're only focusing on what type of subshell you're in, how many maximum electrons you can put it in there after figuring out how many orbitals you could have in that particular subshell. The number in front of the subshell kind of becomes irrelevant. So this 3 becomes irrelevant in that case. So there's a couple of ways you can actually do this. So this is an S subshell, which means it's an S block. So one question you can ask yourself, how many groups in S block you have? Well, if you go back in the periodic table and look at the S block, which is the first two groups, that's going to be 2 groups in there. So that means that's how many maximum electrons you can put in there. But, that's not how you want to be doing it for the most of the part. You better understand it doing the long way. So in an S subshell, how many orbitals you have? Well, we just talked about how you're going to be figuring out the orbitals in the subshells. So since it's an S subshell, the maximum number of orbitals you can have is 1. And how many electrons you can put in one orbital? Well, that's going to be 2 maximum electrons in one orbital with opposite spin. So since in 3s subshell there is only one orbital, the maximum number of electrons you can have in an S subshell is going to be 2. So it doesn't matter whether you have an 3s subshell or 2s subshell or 1s subshell, it will still have a maximum of 2 electrons. Okay, let's look at this next one, which says 4th shell. Well, now we're looking at the shell, which means the n value is actually 4. Here, the L value is 0, but now we are at the n value. So when you have the n value and you're not given anything else, like the subshells or the orbitals, you're only talking about how many total electrons collectively can be placed in a particular shell, you can always use this formula. So remember, this formula only works for the shells, all right? Not for the subshells, not for the orbitals. So max electron is going to be equal to 2n squared, where n is going to be the value of shell. So I'll just go ahead and plug that in there. So it's going to be 4 squared times 2, and that gives you 32 electrons maximum in this 4th shell here. Okay, so then let's look at the next one. It says 4d orbitals. Okay, now sometimes these wordings could be confusing, so that's why I said earlier you got to be really careful how the question is worded here. So it says 4d, sorry about that, it says 4d orbitals here. So that means it's talking about all the orbitals you can have in 4d subshell. All right, because when they have written down the number and the subshell along with it, we are mainly referring to the type of subshell you're in. So how many orbitals you have in 4d subshell? Well, the value of L is 2 for D, so that means you're going to have 5 M of L values. There's actually 5 total orbitals. So you're talking about all the orbitals in there. So each orbital will carry 2 electrons, so that's going to be 10 electrons maximum in that 4d orbitals. Okay, well, I have this next question here. It says 4d orbital, just to kind of make sure you can understand the difference between the 4d orbitals and the 4d orbital. It's more or less like a singular and plural. It's like in the previous question, it's talking about all the orbitals that's going to be in that 4d subshell, but here now you're talking about only one of the orbitals in the 4d subshell. So since we're only talking about one orbital, it's going to have only it's going to have only 2 electrons in there. So we're talking about one orbital in there, and it's going to have 2 electrons maximum. So the question could have been like, okay, how many electrons in 2p orbital? So if it's in a singular, then means it's going to talking about only one of the orbitals in the complete set. And if it's only one of the orbitals, it's going to have only 2 electrons in there. Okay, what about 5s subshell? Well, what we said earlier when we did the first question where we had 3s subshell, we said it doesn't matter whether you're in 3s subshell, 4s subshell, or 5s subshell. The maximum electron is going to be dependent on the L value, which is in this case is going to be 0. That means M is going to be 0, so you're going to have one orbital in there. So since you have one orbital, the maximum electron is going to be 2 in there. Okay, what about 3p subshell? P subshell, how many orbitals you have? So go back and figure out the value of L for P, and then figure out the values of M of L. That's going to come out to be 3 numbers in there. So that means the maximum orbitals you have in 3p subshell, so in any given p subshell, a matter of fact, is going to be 3 orbitals. So that's going to give you a 6 electrons max in there. Okay, what about 7s orbital? Well, it's kind of similar to the 5s orbital. It's going to have only 2 electrons in there. 5th shell. Okay, now we're going back to the shells here, so that means the n value is 5. So to find the max electrons, I can use 2n square, which is going to be 2 times 5 square, and that's going to give you a total of 50 electrons in the 5th shell. You may not have that many visual right away in the periodic table, but once you study the periodic table deeply, you will understand how those electrons kind of placed in there. So that's how many maximum electrons you can put it in that 5th shell. So this is a very common question where they would ask you whether, the shells or the subshells or the orbitals or the orbital, and how many electrons you can put them in there. So make sure you have a good practice on those. Let's talk about the quantum numbers sets, like which ones are going to be valid and which ones are not going to be valid. So, like I said, once you know the n value is going to be the most one that's kind of independent along with the S of L value, but then there are L values dependent on the n value, and your M of L value is dependent on the L value. So if you don't understand that quite well, you need to go back and watch the other tutorial where I have talked about the quantum numbers only in details. Okay, so let's look at this first one. So A says the value of n is 3. Okay, so the possible values of L could be 0, 1, and 2. If it's 3 or more than 3, then it's invalid. And what it turns out to be, the value of L is actually 4, so that means it's going to be an invalid because of the value of L. Okay, so that one is not good. What about second one, B? The value of n is 4. Okay, so the possible values for L are going to be 0, 1, 2, and 3. You're not going to be getting all 4 of them or all those possible values. If you have one of them, that's fine. So in this case, it's 0, so that's good. Now the value of M of L is actually dependent on the L value. So it's going to be minus L to 0 to positive L. So since the L value is 0, the only possible value for M of L you could have is 0, because writing minus 0 and positive 0 doesn't really make any sense. And you're not going to get minus 1 in that there anyway, so this is going to be an invalid as well. Okay, let's look at the next one. The value of n is 3, and the value of L is actually 2. Okay, so far it's good because we want those values to be less than the value of n. Now, the possible M of L value is going to be, I'm just going to write that on the side here, it's going to be minus 2, minus 1, 0, plus 1, and plus 2. And then you want to kind of double check if it fits the range in there, and you have 0 given, and it is in the acceptable range. All right, so that one is fine. And then the S of L, okay, well, what do we know about the spin quantum number? The spin quantum number is going to be either positive half or negative half. Those are the only 2 acceptable values you have for the spin quantum number. So that means there's something wrong with that, and as a result, this becomes invalid. Okay, what about something like the next one? The n is 2, okay. The l is 0, okay, that's fine. It needs to be less than n, and that's fine. And the m of l, the only possible value for m of l is going to be just 0, so that's fine as well. And your s of l is minus half, so that's fine as well. So this last quantum number is going to be the valid one. So it's very likely they will ask you, this is a common question asked in the exams where they give you multiple sets of quantum numbers, and you have to either figure out which ones are invalid, or sometimes they may just ask you which particular quantum number is wrong in a given set. Okay, let's look at this last question here. It's asking you write down all the quantum numbers of 2 electrons in the 4s subshell. So I have 2 electrons in 4s2. So remember how many electrons you can place in 4s? Well, it's an s subshell which carries only 1 orbital, so the maximum electrons you can put in an s subshell is 2 anyways. So let's call that electron 1, and let's call that electron 2. Okay, so let's say the n value, and then you have the l value, you got the m of l value, and then you have s of l value. So your n value obviously coming from the number that's in front of the subshell, which is 4. So both of those electrons going to have 4 n value, or the principal quantum number is 4. For the s value, or for the l value, which is the angular quantum number, that's dependent on which particular subshell you're in. So in this case, it's the S subshell, and for S subshell, the value of L is 0. So it's going to be 0 here and 0 here. Okay, so then you have this M of L value. So this M of L value dependent on the L value, so it's just going to be 0 because writing minus 0 and plus 0 doesn't really make any sense. It's just going to be one value for each. So far, if you look, both of the electrons has the same values of the quantum numbers, and sometimes it's actually the very last quantum number that makes the difference in their address. So now I know there's only one orbital in 4s subshell. Okay, so if I have one orbital, one box here, and I have 2 electrons in there, and what do we say about quantum number, spin quantum number? Says you can place 2 electrons in an orbital, but they must have an opposite spin. So that means one of the electrons will have a positive half value, and the other electron is going to have a negative half value in there. So, like I said, sometimes the first 3 quantum numbers for a particular, for 2 sets of electrons in an atom are the same, and it's going to be the last quantum number that's going to make the difference in their address. And there is a principle called the Pauli exclusion principle, so I'll just kind of write that down here. Okay, so Pauli exclusion principle says that no 2 electrons will have the same quantum numbers in an atom. So no 2 electrons in an atom will have all quantum numbers to be same. Okay, so what that really means, you cannot have the same address in an atom for 2 electrons. Every single electron in an atom must have a different address. So that's the Pauli exclusion principle. All right, so those are the most common questions asked just from the quantum numbers in the exams. And if you have any questions, feel free to leave any comments in the section